Right now, I will introduce our first team, genetic data, potential uses and misuses in marketing. Exponential growth in the direct-to-consumer genetic testing industry, or DTC-GT, has led to vast privately owned data sets containing individual-level genetic measures. Global companies such as Spotify and AirBnB have already partnered with these companies to incorporate genetic data into their business and marketing strategies. So today we are joined by Remy Daviette from the University of Wisconsin and Gideon Nave from the University of Pennsylvania, who will discuss the impact of this trend on the field of marketing with attention to the ways in which genetic data can be used and misused, as well as the ethical challenges it presents for all involved. So welcome, Remy and Gideon.
Hi. Thank you, Paige, for this lovely introduction, and it's really great to be here. I'm Gideon Nave from the marketing department at Wharton, and I'm presenting here work with Remy from the University of Wisconsin Medicine, our co-author Madison, and our co-author Jerry Wind, who is also from the Wharton School. Now, what motivated this work was the rise of genetic data. Nowadays, teams and consumers can access individual-level measures of the human genome. Most of this data was accumulated via the direct-to-consumer genetic testing market. Genetic testing companies, you can see example of this on the left side of the slide, give consumers plastic tubes that they can spit into and ship for genomic analysis. Now, the graph below shows the rapid growth of this market. More than 30 million people have already taken such personalized genetic tests. Now, most revenue to date has come from the selling of kits, but the growth of sales has been slowing down. And genetic testing companies actually seek ways to monetize their data to maintain growth. For example, we have this quote from Patrick Chung, who is a 23andMe board member, who recently noted in an interview that the long game is not to make money selling kits, although the kits are essential to get the base level data. Once you have the data, the company does actually become the Google of personalized healthcare. One way of monetization of this data of these companies, just like Google actually, is by using it for marketing. In September 2018, for example, Ancestry.com, that is a leading company in the industry, partnered with Spotify. You can see it here on the slide. And let Spotify users to upload their genetic data and discover music that matches their genetic DNA. Similarly, we've seen 23andMe, another leading company in this market, that partnered with Airbnb to create services that allow users to discover travel experiences that match their genetic heritage. Now, in this new world where privately owned genetic data is growing exponentially and may be used for marketing, our paper evaluates the impact of this development by discussing potential uses and potential abuses of genetic data by marketing researchers and practitioners. Our paper covers a very large territory, and it includes a review of relevant literature in related fields like behavioral genetics, a framework that extends consumer behavior theory to include genetic variables, and also an agenda for future research. Now, to learn more about this, unfortunately, you'll have to read the paper. And in this talk, I'm going to focus on three other components of these papers. Number one, what is commonly available genetic data like? Second, potential uses in marketing, research, and practice. And number three, ethical and legal consideration. So let's start with the first one. The human genome is a sequence of about 3 billion base pairs. There are 4 types of bases, commonly denoted by the letters A, T, G, and C. These base pairs are actually packaged into 23 pairs of structures called chromosomes, illustrated here in the picture, and are indexed based on their location. So we can refer to each specific one of them by location, and every woman actually has 2 copies of each chromosome, one inherited from each parent. Now, the base pairs in most genome locations are identical across all humans, as illustrated on the right. So they're not really informative about inter-individual variability, but there is a small number of locations, less than 2%, called polymorphisms, where individuals commonly differ. The most common type of such polymorphisms is the single nucleotide polymorphism, in short, SNP. These are locations where a single base pair, as you see in the picture here, differs across individuals. So here we have one person with an A, one with a G, and one with a T. Now, commonly available genetic data quantifies variations in 1 up to 20 million such SNP locations. Now, when considering potential uses and misuses of genetic data, there are several unique characteristics of it that one must consider. First of all, one's genome is informative about virtually everything, from physiological traits like height or BMI to psychological traits like risk tolerance and personality, and even complex real-life outcomes such as the probability of getting divorced is somewhat predictable from the genome. Now, of course, there is no direct causal link between genetics and getting divorced, but because certain heritable traits, like, for example, neuroticism, are associated with greater likelihood of divorce, genomes are also informative about this outcome. Furthermore, because genetics is shared between family members, one's genetic data is not only informative about the self, but also about their non-genotyped relatives. Second, genetic data is immutable. Our genetic profiles are determined at the time of conception and remain stable throughout life. This means that genetic data can be obtained very early in our life, even before life, and can be predictive on various outcomes long before other data types. Third, genetic data is identifiable. With about 100 randomly selected SNPs, we can uniquely identify an individual unless they have an identical twin. This means that unlike other variable types, like demographics or behavioral measures, anonymizing the data is not straightforward, as the information itself is revealing who the individual is. And now I'm going to turn it to Remy.
Thank you, Gidi. So we are now going to describe various potential uses of genetic data in marketing, specifically for segmentation and targeting. One obvious approach is to use variations in a specific gene that is directly linked to a relevant trait. For instance, you can think of lactose intolerance, bitterness sensitivity, alcohol intolerance, which leads to flushing. So they are single gene cases that are easy to deal with, but they are, however, limited. Next slide. So most typical human traits are associated with very many genetic variants, and each of these variants account for a very small percentage of the trait variability. By combining all these small effects, we can create an overall score that is predictive of the trait. Since each effect is very small, we need really large sample, usually several million people, to estimate the effects accurately. In the graph on the right, you can see how the score's accuracy raises as the sample size grows. For a physical trait like height, at the top, it grows pretty fast, and for a social trait like educational attainment at the bottom, it grows slower. For most behavioral traits, with limited sample of a few 100,000, we can already predict 5 to 10% of the variations. So these include adding milk to filtered coffee, 10% of the variation are predicted, and the other ones you can see on the left. With the large samples available to genetic testing companies, many millions of people, the share of explained variations should increase to between 15 and 25% for most behavioral traits. Note that this score can be used in conjunction with other more traditional variables for market segmentation. The field is advancing quickly, and new methods are developed every day, including machine learning methods, finding interaction with other variables, and this accuracy is expected to improve a lot in the future. Another approach is to use genetic data to personalize the message and to promote a sense of community. So one of the most straightforward approaches is to look at ancestry because it can be very easily recovered with genetics. On the left, you can see a graph representing the two principal components, that is the two main dimensions of variations in DNA from a European sample of people. You can basically see that the genetic variation directly recreate a map of Europe showing how strong DNA is linked to ancestry. This is amazing. One application we know of is a campaign by Aeromexico where they offer discounts proportional to the percentage of Mexican DNAs that residents of a small town in the south of the US had, and they made a video of it. Here's another example using genetic ancestry. Amanda here has nearly 3/4 of Ashkenazi DNA and could thus be oriented toward Jewish themed products such as trip to historical places, traditional recipes, or music. Finally, as you inherit randomly 50% of the genetic code from each parent, and since DNA is not affected by your behavior, this can be treated as a natural experiment and help you find causal relations. So in the world of quantitative genetics, this approach is pretty standard and is known as Mendelian randomization. We are now going to discuss part of the numerous ethical challenges associated with genetic data uses. We already mentioned that genetic data is identifiable, so it's very hard to anonymize the data, and this leads to other issues linked to privacy and security. Once a consumer shares genetic data with a business, they take the risk of losing control over it and see some things that can personally identify them and contains information about virtually every aspect of their life being released in the wild. This makes genetic data a critical security concern more than other types of data. Another issue is that consumers are not necessarily aware of all the possible use of genetic data and the implications of sharing them. Educating consumers is not straightforward and not necessarily aligned with business interests, which might lead to business not doing education properly or worse, exploiting consumers in unethical ways. Moreover, since the data is also informative about relative, I did a genetic test, so they have 50% of my mom's DNA. Can they target her based on the information from my genetic code? She didn't give consent for that. So should they delete the data? But it's also mine, and like to have some insight about my genetic code. So do you see the problem here? The lack of education makes the consumer also vulnerable to misleading claims such as, are you born to be a genius, or are your kids future prodigies, leading the consumer to falsely believe that there is a systematic aspect to genetic influences. This has been abused in the past, as you can see here on the slide, and it has led to some backlash. I personally see genetics as a very small part of one's potential, and whether this potential is realized depends on a lot of other factors, but consumers don't necessarily know that fact, unfortunately. Of course, the use of genetic data can lead to discrimination, even if it's not voluntary. What if universities start to accept students who have a higher genetic potential? Or what if I offer a discount to a part of the population based on their genetics? I might be favoring people who are already advantaged in life. So what about regulations? Europe has one of the most advanced regulation preventing the sharing of genetic data, even if it's anonymized, and preventing any other use of the data than the one that the consumer explicitly accepted. Consumers have, however, been known to accept many things without reading or understanding them, limiting the effects of these protections. In the US, genetic data cannot be used by insurance companies to discriminate, but the rest is subject to contract law. For instance, 23andMe has unilaterally modifiable terms and conditions, which states that they won't use genetic data for marketing without explicit consent. With explicit consent, however, they don't mention any limit. They also sold to a pharmaceutical company access to all the data of the consumers who authorized research to be performed. The consumer were not necessarily knowing that the research could be commercial. So the main takeaways, the low cost of genetic testing and the accumulation of privately owned database of genetic data create many opportunities, but also concerns. This new type of data can be used in several ways that are relevant to marketing, and the field is likely to grow significantly in the future. Current regulations are poor, and there are still few ethical guidelines for companies. I thank you for this opportunity to present our paper, and now we are going to open to questions.
Great. Thank you both for such interesting insights and raising the black box and Pandora's box questions that come along with it. Just a reminder to the audience to please use the Q&A tab if you'd like to ask questions directly. We have one, so I will go ahead and pose that to Remy and to Gideon. Do advertising companies purchase the genetic data today, and is that legal? I think you touched on that, but more explicitly, what about advertising companies in this space?
So, to my knowledge, there is no purchase of genetic data. The genetic data is not shared as is, but you can, there is nothing limiting you, if you're outside of Europe, to contact a company that has the data and to tell them, please, can you mail all your clients who have lactose intolerance? I'd like to send them a message about my great soy milk. So even if we were to limit the purchase of genetic data, we might actually create genetic monopolies where the companies like 23andMe will hold all the data and sell them at high price, or sell access to their consumer at high price, like what Facebook is doing, for instance, with social media data.
Yeah, you may be surprised also to know that many people just voluntarily upload their data to public websites. That's actually how the Golden State Killer was caught. So people just put their data online, so you can think of it as a scrapable secondary data.
Great. That raises another question that you did touch on a little bit. How do you think consumers will react to the use of their genetic data by marketers if and when they figure out that that's going on?
It's hard to predict. We've seen several articles recently. For example, the LA Times had an article about BlackRock purchasing Ancestry.com that received backlash. But typically what I see is that after an immediate backlash, like for example, Facebook and the Cambridge Analytica scandal, people go back to their own life and are not necessarily aware of the risks in day-to-day. We do see also that many people are still giving, are still trusting this industry, including myself. Yes, you have maybe the right to be forgotten, but as long as the benefit of doing the genetic test is perceived as greater than the risk, people, I believe, will continue doing so. And maybe will continue also clicking consent for the use of their data for various causes.
Great. You also raised a number of these ethical areas, if and when they do realize that their data is being used. Given these ethical concerns, do you think it's a good idea for these marketers to use this genetic data with all the challenges and opportunities it presents?
I think there is a specific case where it's ethical. It's when it's good for the consumer and the consumer is fully aware of what's happening. So if I send my data to a company that will give me health recommendation, I directly benefit from it. And they might say, oh, you're sensitive to sun, here's some sunscreen that's highly protective. I would be happy to receive that. However, if the data is just used as other kind of data is used right now, which means they take everything and they mine it as much as possible to do targeting, I think that's a dangerous path to follow.
I thought another one of your points was really interesting, that you may not be consenting to giving away your code if it's given freely by one of your relatives. And so I think that is a question that we haven't really addressed much in the marketing area. Let's see, any other open questions coming in?
I have one, if I could jump in, Paige, which is to ask you guys to, you talked about the Spotify example and the Aeromexico, but what other kind of really interesting applications are you seeing that might be, you know, kind of fodder for the imagination of any of the marketers that are listening? How should they, what do you see out there that might be useful to them?
Well, one recent example is the company Misuses. It's a German, it's a big company in Germany, and they sort of personalize muesli to people's nutrition. And they are now offering also genetic testing kits where people can give their DNA and they get muesli recommendations that are tailored to it. We've seen a company called Venom popping up. This is a company that purportedly matches to your genes wines that are going to be more appealing to you. I mean, I actually have a study now that look at the power of genetics to really capture taste preferences. And I have to say that the results are not as encouraging as you would think. So it's not obvious that genetics is going to give you a lot compared to this to other types of data that you can get. But on the other hand, there's certain unique characteristics of genetic data, like you can measure it very early and interfere much earlier. And in my view, this is the strongest potential of genetics. For example, if we think of somebody that is more likely to develop a tendency to become a smoker or a heavy drinker, somebody that has maybe a tendency for compulsive eating or gambling, we may be able to help these people long before they develop the tendencies and protect them. So that's maybe, I mean, we can call it marketing, you can call it policy, but that's maybe the promise. On the other hand, these people are also vulnerable at the same time. So there is a thin line here between, wanting to help the people, using maybe non-paternalistic nudges, or on the other hand, exploiting them. I'm sure that a casino in Las Vegas will be happy to get people just before they turn 21, people who have a genetic tendency maybe to become more risk-taking or develop some addictions to gambling. So there is a very thin line here. And what we hope in this study is just to bring up this discussion, because we are already, I think, too late for it. There are already 30 million people whose data is available, and we cannot be too late in starting to talk about it.
I also, your conversation, and you talked, both of you addressed the mutability of genetics, and I've done a lot of reading on epigenetics, which you didn't talk about. And of course, that for the listeners, that's the idea that genetics can be, genes are sitting there and they get turned off or turned on depending on environments, what you eat, how you act and things. So I don't know if do you see a connection to the way in which we might help consumers or marketers might be able to even think about their products and services as ways to at least not get that gene turned on? I'm just kind of thinking out of the box in terms of, it seems like maybe that's sort of the next, a 2.0 version of your paper.
So we do, and I mean, spoiler, maybe we're even going to submit a paper to the Journal of Marketing soon that deals with it. So one very promising aspect of epigenetics is that it can somehow measure the influence of the environment on you, and because it alters gene expression. And one very promising use in medicine nowadays is to measure something that is called biological age. So of course, our age is chronologically moving along the timeline, but there are a lot of processes related to aging that are not advancing in the same way across everyone. So the idea is maybe we can disentangle this age construct into different sub-constructs. One of them is the biology of aging. So that's something that you can do with epigenetics. There are already companies that are basically giving this service. It's still very expensive, and it's a very early thing. So there are not 30 million people that have this epigenetic data, but that's also a very promising angle that we are looking into, at least in terms of theoretical knowledge. If we want to know how aging is going to impact society, then just looking at older consumer and comparing them to younger consumers in terms of chronological age may not be telling us the full story. And epigenetics measures may be able to help us. So stay tuned to us. Hopefully we're going to come up with some more papers on that in the future.
If I may add, epigenetic data, which is less available, but it's a lot more predictive than pure genetic data, because now it takes into account your life experience. And so far, on most of the variables we've tried, we've reached a really good predictive performance. So I think this market will grow because now there will be incentives for companies to actually accumulate this data instead of just genetic data.
Fantastic. Well, I had it's interesting you mentioned about longevity. That was the context in which I had read about it, about biological age, and so it's really interesting. I think there's a lot of possibilities there, and maybe that's also marketing for good in some sense. We could think about how we could use that to help people turn these genes off and on in a more systematic way, because I think most people don't think about genetics in that way at all. Look forward to seeing the paper at the Journal of Marketing.
Yeah, we do.
Wonderful.